Are we back? Is this working? Hi. So just a heads up, this episode will be another supported by uh, alcohol. So I'm already half a beer in. Hopefully I'll finish this one, grab one more maximum, you know. They're gonna hit me just at the right spot so I can fall asleep like a baby tonight. But if you watched the last episode in which I was drunk and somewhat incoherent, maybe this wouldn't be the best idea. But you know, I'm gonna give it my best. So who am I? My name is the Duke. I created this channel because I was stuck in the web dev rut for way too long, and I wanted to learn something new and to refresh my memory on the technologies that I used to do back in high school and university. And just a second, please. I'm just testing it if my stream is working. Yes. So basically, I'm here trying to relearn everything that I once knew. And what I like, first of all, about the book that I'm following, and the name of the book is Build Your Own Lisp by Daniel Holden. Right? What I like about this book is the fact that it's really, really well written. Especially for someone that basically has a big rot in the place where all this knowledge of low level programming languages should be. Oh man, beer is amazing. So yeah, it's a good book. It's a palatable book, and I hope once I finish it, all the knowledge will be useful. Hopefully. So where did we stop in the last episode? So I started working on the bonus marks, and I think that I wanted to do this guy. Write a recursive function to compute the most number of children spanning from one branch of a tree. Okay, let's do this. Let's do this. So we already solved one of these problems. Okay. So the question says the following. Write a recursive function to compute the most number of children spanning from one branch of a tree. So what do we need to do? We need to find the branch in the tree that has the maximum number of nodes. Basically, they're looking for the longest path, right? And while reading this, while analyzing the question, I realized that it always will span from the root node. So it starts from the root node because we can't have path, unbreakable path, if it's not starting from the root node. So it will start from the root node, and we are looking for the longest path in it. Okay. So how could we do this? Let's do this again. So what do we have? We have a plus here. I'm just writing this again. We have a 5 here. We have a multiply. We have a 2. We have another 5. So oh fuck. What will we do? What will we do is, I assume we'll take a node, then we will start from the root node, and then we will compute the depth of each of its children. So we come here. So I think the depth is 1. So we come back. From this side we have 1. Here we don't have. Here we have 1. We come back, we have 1. Also 1 here. So it's 2. We come here, it's 2. So again, we'll do similar logic like in the last example. Similar logic. Okay, so int most children, calculate children from the output, print f. I'm printing what? An integer, most children. The method is called calculate leaves. The method is called calculate children, right? Int calculate children. It's a pointer to an abstract search tree. Okay. So again, recursively, we need a base case, we need a recursive case. So let's think of a way to solve this. I think we'll start the same way. So if this guy, no, if the node has no children, so if the children num is equal 0, fuck, return 1. Okay, yeah, I don't think this logic will work because we don't have additional node elements and config elements in this search tree. I mean, even if we did, I don't think it will play any role in this exact example. So then let's create a depth variable. So what should I do here? By the way, subscribe to my channel if you already didn't. So the thing, the point about this channel is basically I'm learning as I go, so I'm not an expert in this. As a matter of fact, I'm barely a layman. So that's why I use, for example, a lot of helper tools like ChatGPT or Google or stuff like that. Okay, I just took a quick glance on this. So this is depth. What do I want? I want to go from 0 children num this. Okay, so what is how wait. Okay. Okay, so how will this work? We start here, right? From the root node, and the root node has child elements, so we do nothing. But then for every child of the root element, we calculate the same thing, right? So we come here. Oops, sorry, here. So we come here. Let me remove this. Maybe it will be, yeah, it will be easier like this. Okay. This, 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 this. Okay. So first of all, the root node has child elements. So for each child element, we call the method again. So we have these two guys here. We have these two guys here. So in this case, what do we have? We return 1, we come back. We should also count this one, so it's 2. But on this side, we go another recursive iteration. We come here to this point because it has no child nodes. We will return it, return 1, come back. We return 1. Then I come here. But wait, how? Let me just think about it. How can I know if I already came here? I basically understand what happens if you go from here to here. You basically carry a 1 from the base case. But how can we carry another one up here? That's my question. Turn 1. Step, child, depth, okay. I don't think, okay, let's write it. So, oops, we are iterating through every child, right? So if a node has no children, it's a leaf node. The depth of this node is 1 because there's no branch below it. Now, we also need a recursive case. So in the recursive case, we need to calculate the depth of every element. Yeah, let's see. Int depth calculate children on I. Fuck. If depth is bigger than max depth, so what will happen? We will set max depth to depth, right? And then we max depth. I think that's it. This should be it. Okay, no errors. Okay, plus 2 times 3 and 4. It's 1. How the fuck is it 1? How the fuck is it 1? So it's what was my example? Plus 2 times 3, 4. So it should be plus 2 times 3, 4. It should be 3. It should be 3. Why isn't it? Why isn't it? Why? Sorry, let me just do another example. What if I say plus 2, 3? It's 1. It's 1 again. Plus 2 times 4 plus 2, 3. Will this work? No, it's an error. Why? Why? Plus 3, 4. Times 1, 2. It's still 1. Okay. So there is a huge fault in the logic here. There's a huge fault in the logic here, and I have no idea what's the fault. Yeah. Mm. Why doesn't this work? Okay, I know that I need to add 1 here. Ah, fuck. Yeah, it's 3. It's 3 plus 2 times 3 times 1, 2. It's 4. It works now. It works. What were my examples? Plus 2 times 3. Plus 2 times 3 and 4. So, okay. Ah, okay, now I got it. Now I got it. Okay. So what will happen? The following will happen. We start from the plus. We start from the root node. And then, how can I, let me just divide this somehow. Yeah, yeah, like this. Like this. So if the abstract search tree, let me just remove this and increase the size, change the color to, I don't know, let's put purple. So what do I have? What was the example? I forgot. Plus 2 times 3, 4. Okay. Plus, I want purple. Plus 2 times 3, 4. Okay. So what happens here? We start here from the plus. This is the first iteration. This is the first iteration right here. This guy. Okay, we start here. And then we check if this abstract search tree doesn't have any children, we should return 1. But in this case, it does have children, so we skip it. We create the variable max depth here, and we set it to 0. And then for every child, including this one and this one, we call calculate children again. So for this guy and this guy. So here we calculate children. We return 1. We come back, and here's 1. Now this guy has 2 children of itself, so we go down here, and then we have here 1 and here 1. Now we are at the position in which we are coming back, so we are looking, our max depth here is what? 0. Here we have 1. Here we have 1. So we are comparing if our current depth is bigger than our max depth. It is. So we set our max depth to 1. So it's not 0 anymore. It's 1. Okay, so it's not 0 anymore. It's 1. Okay, now the other guys. So we already have here 1. So we come here, we come back. If depth is bigger than max depth, come here. And here we have a 2. And here, what do we have here? It's 2. Max depth 0. String here. Yeah. Yeah. I think I understand it. Oops. I think I get it. Okay. How would you use? Let's do another problem here. How would you use string substring, right? To see if a node was tagged as an expression. How would you use string compare to see if a node has contents like this? Okay, let's do all of these. I think a really good way to learn is to do all of these. Bonus marks, maybe not all of them, but some of them. How would you use to see if a node was tagged as an expression? So what can we do? How would you use? I think what we could do is we already did here. Yeah, we can do something similar to this. We can check if its tag contains the substring expression by using a substring like this. Only instead of a number, we would use expression here. Because what are the scenarios here? Where are you? Here. Okay. A node can have a tag. Oops. A node can have a tag of this of expression, or I don't know, number or operator, or a variation of these. So basically we are checking for this substring, and this is using this we can check if a node is tagged as an expression. Okay. So we finished another one of these. How would you use string compare to see if a node? Just use string compare. Okay. Add. I'll listen to this. Add the operator modulo, which returns the remainder of division. For example, modulo 10, 6 is 4. Okay. So for this, we'll need to edit first things first. I think I'll comment out. Wait. This, no. Where's the... How do I... Ah, here. first things first, we need to add modulo in the operator list here. So another or, and this guy. No, it's not. Ah, it's already here. Okay, it's already here. So considering that's already here, the only thing that we need to do, so just a reminder, we are at the operator, we are solving oops, we are solving this example. At the operator modulo, which returns the remainder of the vision. Okay. We need to add the modulo string compare if the operator is this. What should I do? Hopefully C has implemented this. I mean, it should, right? It should. It should. Ah. What have I done here? Ah. How to replace a character with r like replace. So here r this, here r this. It should work now. Yeah, we just use different quotation marks. Yeah, if I do this, that's it. Yeah, it's full. Okay. What does the book said? What is there anything new in the book? Is there anything new in the book? Okay, add the operator square, which raises one number to another, for example. Okay. Where are you? Same thing, more or less. Same thing, more or less. Or this dude. Do I need to close it? No, I don't need to close it. Okay. Okay. there are built-in not square method in C++. In C, sorry. X. I don't think this will work. I don't think this will work, but let's see. Oh, it works. It's 6. Why is it 6? How to square a number in C? Ah, I can do it like this. Or I can use the power function. Okay. Okay. Vim. No. I want to square it. Yeah, I want to square it with the yeah. So yeah, I should do something like this. Int pov x epsilon. Should be like this. For 16. 4 3 should be 64. 4 4 should be 256, right? 4 5 should be what? 1024. 4 6 4096. Okay. Add the function min, which returns the smallest number, and the function max, which returns the biggest number. Error handling is the next chapter. Okay, let's do these two problems, and we'll wrap this chapter completely, so we can focus. We can switch our focus to the error handling. Okay. Okay. Where's the code? It's here. So what should I do? I'm going to the operators list. I'll add min. I'll also add max. Let's do both of these at the same time. Okay. But wait, I don't. Ah, shit! I don't handle these guys anymore in the eval operator method, because they can take more than two for the two operators. Okay, let me just throw the beer can. Bourbon. Okay, so what goes in here is the following. Both min and max can take more than one argument, as defined here. At the function min, which returns the smallest number. For example, min 153 is 1. Okay, so we need to find another way. I can't just change the switch operator method. Okay, where is it? Where is it? Where is it? Where is it? It's here, right? This is the operator. This is the operator, right? So how can we do this? So this is an abstract search tree. Children. So I have the operator here, and I need to handle it here. So if string compare operator is minimum, and it's like this. I should learn that C++ only handles double quotes. Okay. Okay. Unused variable. So what should we do here? Ah, okay. Uh, so how do I set how do I put a breakpoint? Okay. Hmm? Why is this not working? Why is this not working? It's not working. Why? Why is the parser undefined here? Why is the parser undefined? Wow. Seems like everything is broken now. Seems like everything is broken. Could it be that the max should be removed because I don't handle it at all? No, it's not. It must be the min as well. right? Yeah, it is the min. So it was the min the whole time. Okay, web. The min. The min is creating some issues here. Why? Why? It still doesn't work. But the worst thing is I can't even debug it. Yeah, I can't even debug it for some reason. Wow. Whoa. Hmm. Nah, fuck, I don't have time for this. So, coming from my pretty limited knowledge of the C programming language, it seems it seems is something broken here? No, it should work. It should work, right? It's a new operator. We are parsing it from the standard input. We take input. This is the language. Why? Let's be fucking kidding. Like this, right? I made I made ChatGPT write this because I'm at a point in which I don't know what's happening. Fuck. Yep. Evil. I need to debug this. I have no idea what's happening here. I just write. Fuck. I'm just. Why? Oh. Ah. No! Fuck! Yeah, BM. Why? Why? Fuck, God. Ah, I have no idea. I have no idea why this happens. Uh, and why this happens. No, no, it doesn't work. It doesn't work for some reason. Doesn't work for some reason. Let's see what ChatGPT says. Uh, so this is what ChatGPT is saying. Ensure proper parser initialization. But I think I do have it, right? What? Why do I have 3 walls here? You know what? Let's continue this at a later time. At a more sober time. I need to end this. Bye.